So hi everyone, welcome to Data Science Works, and today I'm going to discuss with you all is a very important topic in machine learning, that is unsupervised learning. So in the previous sessions I have explained you what's the difference between supervised versus unsupervised. So in supervised we have the labeled data set, and in unsupervised we don't have the labeled data set. So I've provided you the quick recap, like what do I mean by supervised versus unsupervised. Now let's deep dive into the unsupervised learning with me. So are you guys ready? In unsupervised learning is basically a type of algorithm that is learning the patterns, okay, from the data that is unlabeled. So first of all, let's understand what is clustering. So for example, you have unlabeled data set. So from the, like, we can see it is a circle and it is a triangle, but it don't have the labels. So what we can do, when we have to cluster this, so cluster means what? I'm grouping the similar things together. So what looks similar to me? These circles are looking similar to me. Okay, they are green in color and the shape is also same. Let's group them into one cluster. And these triangles are looking same. Let's group them into another cluster. So I can say in simple plain English language, that is grouping similar things together such that the objects in the same cluster are more similar to each other than those in the other cluster. For example, this is a cluster 1, this is a cluster 2. So objects in this cluster will be more similar as compared to objects in the other cluster, right? So what are the applications? If someone asks you, okay, you are applying, what are the applications where you can easily apply clustering techniques? So customer segmentation. So there's some kind of customers that are only, interested in buying electronic items, and there's some kind of customers that are only interested in buying clothes. Okay, so there's one cluster called gadgets, right? And there is one cluster like where people are more interested in buying the clothes. So these two clusters, so it helps in customer segmentation. Next is document clustering. We have different documents, a group of documents, and now you want to cluster those documents based on the, you can utilize multiple Next is, this is one of the most important algorithm. People ask you in ML interviews also, that is k-means clustering. So what is K here? K is predefined and it denotes the number of clusters. So let's decode this k-means one by one. So k-means clustering is an unsupervised learning, okay, and it is an iterative algorithm that groups the unlabeled data set into k different clusters. So say you want to check about 3 different clusters. So k-means will group the data set into 3 different clusters so that each item will belong into the one cluster. So why I am, focusing on that each item will be belonging to only one cluster. So this is the point to note here. Next is K. K is predefined and it is denoting the number of clusters. So you have to set it the value. Next is, what do I mean by the k-means algorithm? Now from the previous slide you understood, okay, what I need to do. But what actually k-means algorithm, what's the maths behind it, what's the equation? Let's check in this slide. So given a set of observations, so you have these data points x1, x2 up to xn, and where each observation can be a d-dimensional real vector, right? So each observation can be a real vector. Now k-means clustering, what it is trying to achieve, it is trying to partition your n observations into different clusters, k different clusters, so that to minimize the within cluster sum of squares. So okay, for example, say you have 10 data points, and now I say, okay, I need 3 clusters, right? I define k to be 3. So what I need to do, I need to partition these 10 data points, okay, into 3 different clusters such that objects in the same cluster are more closer to each other. And what I can say is this, to minimize the within cluster sum of squares. So what is within cluster sum of squares? Sum of squares. So for example, I have to go to 3 clusters. So I is equal to 1. So what will be my k? K will be 3 in this case. And for each cluster, what you're trying to achieve is the distance of that point minus the mean of the points in that cluster, that is the centroid also, you can say. So we are calculating the distance of every point from the cluster center, and we have to choose for which the distance will be minimum, and that point will belonging to that cluster, and we have to keep on doing this for all the clusters, and then we sum it, and that's your k-means algorithm is trying to achieve. Now, this is the equation that you have seen, but let's check step by step. I mean, it's okay if you don't understand this in, now, but with each step, I will show you how you can do that graphically also and with easy, simple steps. So let's check the steps now. So first step is very easy, like choose the number of clusters. So how many clusters you want? Suppose we choose k is equal to 3, means 3 clusters we need. Next is randomly select 3 data point as clusters. So you can randomly choose. It's not defined that you have to choose this point as your cluster, center, like the initial. You can choose any, and that is completely random. So I have denoted that by red, green, and blue. Okay, so I'm going to show you the initial data points as a centroids that I have selected in the below image. So I have these data points, okay, and I randomly selected this to be my initial centroids. Why I selected 3? Because I defined k is equal to 3 in the initial settings. So this was my step 2. Next is assign all the points that I already explained. Assign all the data points to the closest cluster centroid. Okay, for example, let's check this. So these are your all data points. And now we have to calculate the distance of each data point to each cluster, and whatever it is the minimum. For example, I calculate the distance of this data point from this, call it as D1. Now calculate the distance of this data point to this, call it as D2. Calculate the distance of this data point to this, D3. So whichever will be minimum, the point will be assigned to that. So you can see from the graphical also. So this distance is larger. Say this distance is just 2 units. Assume this distance is 3 units and this distance is 5 units. So what I need to select? The 2 one, right? Because the distance is the minimum. So you have to select it. Now you have to assign all the data points to the closest cluster centroid. And that's how, this belong to red cluster, these all are belonging to green clusters, then this all are belonging to the blue clusters. That you can easily do by calculating the distance. Now you have to recompute. As I already told, it is the iterative algorithm. So you have to recompute the centroids of newly formed clusters. So this is the step 2. We go from initial. I selected 3 random data points as my initial clusters, centroids. Next, I calculated the distance and selected it to the minimum. And then you have to recompute. Why recompute? Why you're doing recompute? Because initial the cluster center was that, but when a new data point is coming into this cluster, then the center of the cluster will also change. Now you have to recompute the centroids of the newly formed clusters. Next is you have to repeat 3 and 4 steps that I explained until convergence has been reached. So this is a complete recap that I'm going to show you now of the entire k-means algorithm. Remember this as the graphical way. This I have taken from Wikipedia, this image. So first of all, first step, what I did, I selected 3 random data points as my clusters. Next step, I computed the distance of every data point to these cluster centroids, and whatever the distance was minimum, that data point belonged to that cluster. Now, because new observations came into those clusters and the cluster center will change. So this is the step, and you have to repeat these steps until convergence has been reached. So what do I mean by convergence and what's the stopping criteria? Let's check in the next slide. So convergence, there will be some criteria when we have to stop. I said, okay, it is an iterative algorithm, but you don't have to keep going on and on. You have to set some criteria. So I can say, okay, run this k-means algorithm for say 10 iterations. So if 10 iterations are reached, you don't do more. Next is centroids of newly formed clusters do not change. Like I have explained in the previous slide, you have to repeat until convergence has been reached. So, but okay, you are repeating the steps, but the center of the cluster is not changing. So that means what you have to do? all you have to do is stop. Next is data points are remaining in the same cluster, so they are not changing, right? So there's no point in applying the k-means again because they are in the same cluster. So that was about convergence and the k-means algorithm. I hope, I made it clear with the help of the previous slide that I want to show you with all these steps, right? So you can, have a look at that. So that's all for today.